Dalton's atomic theory. A theory, remember, is an explanation of why and how, not just an observation. An observation is a law, but observations lead to theories. So observations about nature include that most natural materials are mixtures of pure substances. Even the water, water in a river is not pure water, it's a mixture. It's got things dissolved in it. So we rarely encounter pure substances. Pure substances are either elements or combinations called compounds, and we've talked about that. A given compound always has the same proportions of the elements, proportions by mass. So if you took water and you decomposed it into hydrogen and oxygen and measured the masses and got a ratio, and you took another sample of water and decomposed it and got the masses and got the ratio is going to be the same. It's always going to be the same. The law of constant composition, now this again is not explaining, this is just stating this is what is. This is what we observe. A given compound always has the same composition regardless of where it comes from. Purified water from the King's River, purified water from the Nile River, exactly the same. Okay. Ascorbic acid, vitamin C, if you make it in the lab and it's pure, it has exactly the same composition as vitamin C that you would isolate from rose hips or from some other organic source. It's exactly the same. So water is always 8 grams of oxygen for every 1 gram of hydrogen. Carbon dioxide is always 2.7 grams of oxygen for every 1 gram of carbon. Those ratios are always the same. I won't quiz you on those ratios. So Dalton's atomic theory was back in the early 1800s. And I'm not going to quiz you on people's names either. I want you to focus on learning the chemistry part, not the history of chemistry part, which is very interesting, but this isn't a history of chemistry class. So Dalton's atomic theory, this is trying to explain these observations. So the first principle here is that elements are made of tiny particles called atoms. All atoms of a given element are identical. I'll just give you a heads up. A couple of these aren't quite true. Atoms of a given element are different from those of any other element. So he was saying that atoms of carbon, all atoms of carbon are identical, and those atoms of carbon are different from gold atoms or oxygen atoms or sodium atoms. Atoms of...
Would they be different in their weight if they were smaller then? So would that make them different?
The two different elements? Yeah, mass of the atom would be one property that would be different between, say, gold and copper. And we'll find out, though, that atoms of a given element sometimes are slightly different from each other. Yes. So atoms of one element can combine with atoms of another element to make compounds, and these compounds always have the same relative numbers and types of atoms. So the observation was that the ratio by mass is always the same. The explanation is, the reason that is because it has the same numbers of atoms of the same kinds. So here's an example. So here, nitrogen can combine with oxygen, and it can form 3 different compounds. We can have 1 nitrogen and 1 oxygen, nitrogen monoxide. And it's always going to be the same, 1 nitrogen to 1 oxygen. Well, if it's the same 1-to-1 of particles, then the mass ratio is going to be the same also, right? Another one is nitrogen dioxide, 2 atoms of oxygen for every 1 nitrogen. And so that compound is always going to have the same relative numbers of atoms. And then there's another one, dinitrogen monoxide, 2 nitrogens and 1 oxygen combined together. And so they can combine in different ways, but in a given compound, it's always going to be the same relative numbers of atoms. Squeaky chair. Another point in his theory, atoms are indivisible in chemical processes. They're not created or destroyed in chemical reactions. A chemical reaction simply changes the way the atoms are grouped together. Oh, I thought we had a picture there. No picture. So we'll paint a mental picture. This is where I've got a lot of mental pictures. They're much prettier than anything I can actually draw. So this is where the analogy of atoms being like Lego bricks is helpful, because we can all, even though I keep forgetting to bring them to class, I sometimes remember, but I haven't this semester, even though we can't actually physically see them, we can all imagine them because that's something that we've seen before. So atoms are like the Lego bricks. They're indivisible. You can't break them with your bare hands, right? You could cut them with a hacksaw, but that's not normal playing with Legos. Some of my children might try that, but they're kind of weird. So the atoms are indivisible, and when you have a chemical reaction, all you're doing is you're taking those Lego bricks and you're rearranging them. You're having one little, let's draw a picture. That's not very good. See, I told you, my mental pictures are much nicer. Good grief. Start over. Okay. Okay. So there I've got, I'm trying to get different colors here, because Legos are different colors, right? So here I've got a little compound. It's kind of a boring compound, isn't it? But that could undergo a chemical reaction and form something new. Can you see that happening with Legos? You got this one little simple structure, and you take it apart and you put it back together in a different way. Did I create any Lego bricks? Did I destroy any Lego bricks? I just rearranged them. And that's what happens with atoms. And this rearranging of atoms can be pretty dramatic. I mean, we saw some things happen in that first lab, right? Mixing white powdered sugar and some clear acid, and then all of a sudden this big black thing grows out of it. Like, wow, that's pretty dramatic. Nothing was created or destroyed there. It was just rearranging the atoms. You missed that one, Cody. So, concept check. Which of the following statements are still believed to be true? So I kind of mentioned that some of them are actually not true. Elements are made of tiny particles called atoms. Is that still true? Yeah. All atoms of a given element are identical. That one's actually not quite true. They're very similar, but we'll find out about something called isotopes. And atoms of the same element can actually have slightly different masses. And their properties might be slightly different, but it's pretty close. But that one's not quite true.
Is there a component of it that needs to be the same in
Yes.
order for it to be a hydrogen atom?
Yes. Is there a component of an atom that needs to be the same in order for those to be members of the same element? Yes. The number of protons is what makes it a particular element. There's also neutrons and electrons that we'll talk about, and those can be a little different, but it's the protons that make it part of that element. How about number 3? A given compound always has the same relative numbers and types of atoms. That is still believed to be true. Atoms are indestructible. Are atoms indestructible?
No.
No. In normal chemical processes, they are indestructible, but in a nuclear process, they are not. Atoms can be split, and atoms can be combined to form larger ones. And that's how we make these new elements, is by smashing smaller particles together and making bigger ones. They're not stable, and they fall apart really fast, but you can make them. It's like, oh, we made a new one. It lasted for like 2 milliseconds. Atoms are indestructible is also not considered to be true.